Functions and mappings, make some notes and we'll press on. So we're going to be looking at mappings. We're going to look at three types of mappings. Mappings transform one set of numbers into a different set of numbers. And as it says, it can be done by words or using algebra. So this is the first one we're going to look at. Add 3 to the set of numbers 3, 1, 4, 6 and x. If we do that, if we set up set A, then we transform them with the mapping of add 3 into set B. So minus 3 becomes 0 if you only add 3. 1 plus 3, 4, 7, 9 and x add 3. So as you've been, you're used to doing this. This is something you would have done with functions in primary school, and we do this all the time, where we take a set of values x and then we map them to a range of values y. And that's our graph of the values that we put in here in set A map to the corresponding values over here. So minus 3 becomes 0, 1 becomes 4, 4 becomes 7, 6 becomes 9 and so on. So they've mapped from here to there. The original set of numbers, these numbers here are our x values, and it's called a domain, and the values we have here are called the range. So make some notes on that. The original set of numbers known as the domain, and then the results. So your x values are the domain and your y values are the range. Hit pause, make some notes, and we'll move on. One thing to note with these values, one value in set A gives you one value in set B. One value in set A again gives you one value in set B, and so on. So they map from one value to one value. Let's have a look at another example. So this time it says square the set minus 1, 1, minus 2, 2 and x. So we're going to square those numbers. These again are our domain, our x values. So those are our x values. And then we're going to transform them or map them to our range. So minus 1 squared gives us 1. When we square 1 though, we also get 1. So two values in set A gives us the same value in set B. When we square minus 2 we get 4. And when we square 2 we also get 4. So when we square x we get x squared. So many values in set A give us one value in set B. And we can draw that, it's a quadratic curve, and we can see that minus 1 and 1 will give us the same value of y. So from our domain, many values will give us one value. If you look at 2 and minus 2, two different values, they map to 4. Okay. Again, I think this is worth sketching for some notes. So hit pause. When you're ready to move on, hit play again. So we're going to look now at functions. Okay. A function is a mapping when every element in the domain is mapped to one element in the range. So we have a look at an example. So basically there's only one, it can only map to one value. Every value of x can only map to one value of y. So we've got the first one is a one-to-one type of function. So everything in set A maps to one value in set B. So if you have a straight line, y equals x plus 5, every value that you have for x will have a unique value. Every value of x will have a unique value of y. Same thing, another straight line here. Every value of x will have a unique value of y. So that's a one-to-one type of function. Next, we have a many-to-one type of function. So illustrated as so. So we have our quadratic curve, as we saw in the example earlier. You can have more than one value here that will map to the same value in set B. So this is called a many-to-one function. So we've got a quadratic, we've got a negative and a positive quadratic. Okay, and the third mapping is not a function. Okay, in this case here, what we have is the value from set A either doesn't map to set B, or it maps, one value will map to many values, more than one value in set B. So this is not a function. So those are three types of mapping: one-to-one function, many-to-one function, and then the mapping where there are either no values in set B or there are more than one. So I think it's worth making a sketch of those three types of mappings then. Hit pause when you're ready to move on, hit play again. Non-functions include square root or reciprocal functions. Let's have a look at them graphically. So some more notes for you. The value in the domain is mapped to one value in the range. So we have a value in the domain here. The x maps to just one value in the range. Same thing with a straight line. Each value of x maps to one value of y. It's a one-to-one function, many-to-one, like we looked at our quadratics. So if we look here, you can have a negative and a positive value that will map to the same value of y. There's our quadratic. There's our negative quadratic, same sort of thing. So those two values of x map to the same value of y. And then not a function, we've got a circle there. So as you can see, one value of x will give us two values of y. So this is not a function. Same thing here. So the function 1 over x is not a function, it's not a mapping, because it has no value when x equals 0. So a reciprocal has no value when x equals 0. Make some drawings, make some notes. So hit pause when you're ready to move on, hit play again. Right, an example. So hit pause, write it down, and then when you're ready, hit play again. So we've got our function g of x equals to 2x squared plus 3. Find the value of g when x equals 3, and then find the values of g of a when g of a equals 35. So we do part A first. Here. G of x is given by 2x squared plus 3. When x equals 3, we got 2 times 3 squared plus 3. So that's going to give us 2 times 9, 18 plus 3, which is equal to 21. And for part B, g of a equals 35. That means 2x squared plus 3 equals 35. So 2x squared add 3 equals 35. I know you can solve this. 2x squared is going to be equal to 35 minus the 3, which is 32. So 2x squared equals 32. X squared is going to be equal to 32 divided by 2, which is 16. It's x squared, so x is going to have two values, positive, the square root of 16, positive and negative 4. So if you want to hit pause, make some notes, and we'll carry on with this question. And for part C, we need to find the range of the function. In order to do that, we need to sketch the function first. Now we know it crosses it's a quadratic, it's a happy quadratic, and it's crossing the y-axis when x equals 0 at 3. So when we sketch it, it looks like this, happy quadratic, crossing the y-axis at 3. So the lowest value it can take in the range, which are the y values, is 3. So it goes up from 3 to infinity. So we can say that g of x, it can be 3, but it's always greater than. So any value, including 3, up. So we write g of x is greater than or equal to 3. Some notation for you. We can write x is in the real set of numbers, which means then x can be take any value in the reals. X is the domain, and we can write g of x belongs to the real, so it can take any value in the real set of numbers. Reals being any number on a number line. Negatives, square roots, anything on the number line. Okay, we're not going to talk about imaginary numbers, it doesn't belong to that, so we don't touch imaginary numbers in this course. Now then, a mapping which is not a function, we can change it by restricting its domain. So we can, by restricting the x values, we can make a mapping that's not a function into a function. So if we take y equals the positive square root of x, we can sketch it like so. And we've only taken the positive values, so it's a one-to-one function. But it has to start from 0, because there are no negative values of x for which this works. So if we say that x is greater than or equal to 0, then we have a function. You can write it like this: f of x is equal to the positive square root of x, where x is in the reals and x has to be greater than or equal to 0. And we've turned this into a function then. So make a sketch, make some notes, and we'll go on to another example then. Example: find the range of the following function and then state if it's a one-to-one or a many-to-one function. Looking at that is f of x equals 3x minus 2, which is a straight line. So what do you think? What type of function do we think that's going to be? Well, let's work through it and find out. So f of x has domain of x from 1 to 4. So if we sketch the domain as 1, 2, 3, and 4, and we map them then using 3x minus 2 to the range. So when x is 1, function or y is going to be equal to 3 minus 2, which is also 1. So that maps to 1. When x equals 2, we've got 3 times 2, 6 minus 2, so that maps to 4. So 2 maps to 4. When x is 3, you got 9 minus 2, so 7. 3 maps onto 7. And when x is 4, we got 12 minus 2, which takes us to 10. So 4 maps to 10 is our range. So what type of a function do we think it is? Is it a one-to-one or a many-to-one? Yep, it is a one-to-one function. So f of x is a one-to-one function because each element in the domain maps to 1 in the range, so it's a one-to-one function. Hit pause, make some notes. We can also write the range as as a set of values 1, 4, 7 and 10. So another example. Find the range of the function and state if it's one-to-one or many-to-one. So we've got g of x equals x squared. The domain, x is in the reals from -5 to 5. So our first step is to sketch this function, which is quadratic. Being quadratic, what do we think it could be? One-to-one or many-to-one? Let's sketch it and find out. So x has values from -5 to 5, and if we sketch it then by plugging the numbers in, -5 gives us 25, -4 gives us 16 and so on, 0 gives us 0. We have our quadratic curve. Now as we say, -5 and 5 give us the same value, so many values of x will give us the same value of y, which is 25, and our range of values for the function start at 0 and terminate at 25. So it goes from 0 to 25. So we can write the range of the function as 0 less than or equal to g of x less than or equal to 25, going from 0 to 25. And what kind of a function is it? Like I say, -5 and 5 give you the same value. So many values from the domain will give you one value. So it's a many-to-one function. Good. Make a sketch, make some notes, and we'll have a look at the next example. So we've had a look at a one-to-one function and a many-to-one. And we've got this one, reciprocal. Now we said earlier the reciprocal was not a function, but in this case they've given us a domain, and they say x is in the real numbers from 0, is greater than 0, up to 3. So if we sketch 1 over x in the first instance, we're sketching it, we will have, well, if we start at when x is equal to 3, what we get a third. So x equals 3, we start at a third. When x equals 2, we start at a half, or we go to a half. When x equals 1, 1 over 1, so it's 1. And then it goes towards 0, but it never gets there. So now we're dividing by fractions, so numbers less than 1. So it gets progressively bigger and bigger because we're dividing by smaller numbers than 1. So there's our curve. So our range goes from a third upwards towards infinity. So it goes bigger and bigger and bigger and bigger, never quite getting there. So starting from a third, and it goes towards infinity. That's our range. So the function is greater than or equal to a third. It can take any value going towards infinity. And it is going to be correct, a one-to-one function. Hit pause, make some notes. When you're ready, hit play again. And our final example. We've got our function is defined by two equations, 5 minus 2x, where x is less than 1, and x squared plus 3 when x is greater than or equal to 1. So our first step is to sketch the function. So we're going to sketch this function, which is a straight line, for values of x less than 1, and then this function values of x greater than 1. And then in the second instance, we're going to find values of the function equal to 19. So we equate each of these equations to 19 and then solve. So, sketching our straight line, y equals 5 minus 2x. It's going to intercept the y-axis at 5, and it's got a negative gradient of 2. So sketching that. That's our straight line. 5 minus 2x. For values of x less than 1. And for values of x greater than or equal to 1, we've got our x squared. So at 1, that function is going to give us 1 plus 3, which gives us 4. At 2, it's going to give us 4 plus 3, at 7. And so we've got our curve going upwards from there. So those are our two functions look like through the domain values, from minus x values up to through plus values. So that's our sketch. In the second question then, find the values such that the function equals 19, which means we're going to solve each of these for 19. The range of values starts at 3 is our lowest value of y and upwards. So the range of values of f of x is greater than 3. Can't be equal to 3 because this value here doesn't actually get to 1. And for part B, just got to equate the equations. 5x minus 2x equals to 19 and solve. Quite good at doing this now. Taking the 5 over to the other side, minus 2x equals 14, so x is going to equal to minus 7. And with the quadratic one, x squared plus 3, taking the 3 over the other side, we get 19 minus 3 gives us 16, so x is going to be equal to plus or minus 4. But this value is greater than or equal to 1, so it can only take the value of 4. Job done. Now it's your turn. Do some questions for me. Classwork for you, exercise 2B. Quite a few questions to get through here. Get through as many as you can. Good. Good luck.